All right, welcome to our amplifier testing videos. This will probably be a series of videos, just doing a quick overview of checking our amplifier PCB board's features before we assemble the whole subsystem. Right now it's just an amplifier board attached to a heatsink because it does get very warm and it needs a heatsink to dissipate that heat. And we're connected to a mode select switch to switch between AM and SSB mode. I will discuss that in its video in a little bit more detail, as well as a amplifier bypass switch. And also we're connected from the radio to the input of the amplifier board right here, goes through the amp to the output, which goes into a series of SWR meters. I have two. I have an analog on the bottom, and I have a digital on the top. The reason why I have both is that the digital isn't very good testing the bypass because it's meant to be tested really. Even though it goes 0 to 200, it's better from about probably 20 and up, at least anecdotally from what I've read and from what I've observed. Whereas this analog has a scale switch, so you can switch from 0 to 30, 0 to 300, or 0 to 3000. So if we're testing below 30 watts, this one's a bit more accurate, and it also just shows a good general curve of both. If you see that 2 meters are getting relatively similar results, you can be confident at what you're putting down for your power in versus power out, which I was recently doing to make a power in versus power out graph. You can be confident it's fairly accurate. Now I just want to say that this testing will be done on the 10 meter amateur radio band at a frequency of 28.4 megahertz. This is all being done in compliance with Industry Canada standard. I am licensed to operate on this band, along with any HF band for that matter. But I chose 10 meters because my antenna is best matched for 10 meters. So it has the lowest SWR at that, which means we're getting the most forward power, the least reflected power. So to start, why don't I do a test? If you notice, I will be testing on AM initially. I like to test on AM mode because it sends out a constant carrier, so it's very consistent. SSB is a little bit trickier. We'll discuss that later. But let's do a little test on AM. So I'm going to set it to 1 watt of input power. And I'm just going to check to make sure my amplifier board is on. It is. I am checking my mode select switch that I am going to the right mode. We'll discuss that more. Now let's watch our meters. So I'm at 1 watt of input power. What are we going to get? So testing, this is VA7HTG, testing amplifier at 1 watt of output. So it looks like for 1 watt, we're getting anywhere from about 25 to 30 watts of forward output power, which is not bad at all. That's quite good. All right, welcome to the next video testing the amplifier board at its own subset. In this video, we're going to overview the bypass switch. So this circuit has been designed to have a bypass switch. Basically, how this circuit works in a general sense is it is used as a carrier operated relay. So when you transmit RF from your radio, from your microphone, it opens this relay and allows the RF to flow into the amplifier circuit, be amplified, and flow back out through the output. However, when there's no power applying to the PCB board, the relay goes into a bypass mode. So the signal will instead just flow in, go through the relay, and out without being amplified. So our bypass switch is essentially a power switch. So right now it's on, but if I take it and I turn it off, and I transmit my 1 watt power, we're going to go look at the needle meter, because as I mentioned, it's a bit more accurate at the small scale than the digital is. We're going to put it down to the 30 scale. So look at our bottom scale, and we're going to transmit. We're going to go testing. We're getting about about 1 watt, which is exactly what we're putting in, so it's looking quite good. Testing. And now we're going to go and turn so that's our bypass on. Now we're going to switch our scale back up a bit. We're going to go and turn our bypass switch to amp on or bypass off. So our amplifier circuit is now on. And we're going to start our test. So let's go. We're at 1 watt. So testing, 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 testing. This is VA7HTG. Testing 1 watt of output power into our, 1 watt of input power into our amplifier, getting around 26 to 30 watts of output. And now let's go switch the switch off again. Testing, testing. Oh, sorry, I have to change my scale. As I mentioned, you can see it gets a little bit higher in there. These meters are not perfectly accurate on the small scale. That's why these more accurate but harder to read analog meters have a 3-way scale, so you can really tune into what you want to look at. So let's look at our lower scale. Testing, testing. We're at about 1 watt. So that's how our bypass works. So you shut off power to the circuit, the relay goes into bypass mode, and it allows our signal to transmit through without being amplified. Now this can be useful for diagnosing problems, or if you want to operate at a lower power, you're not looking to send out so much RF. Maybe you're in a noise-free area and you're running off a battery. You don't want to burn your battery out when you don't need to. Or maybe you want to use a antenna tuner that's on your radio, and you don't want to have the mismatched circuit kind of mess with your tune. You switch it to bypass, you tune it, you turn your bypass off, and now you have a relatively well-tuned radio to your antenna. Get a little bit less reflected power. The bypass is just a useful feature. In the next video, we're going to look at the mode select feature. All right, welcome back to our testing of the amplifier board before the entire amp is assembled. In the last video, we looked at the bypass switch and how convenient it can be. Now I'm going to switch the bypass switch to amp on or bypass off, because we want to see it with some nice chunky power. Why not, right? And in this one, we're going to look at the mode select. So if you noticed previously, I've been using AM as the primary mode. This is because AM emits a constant carrier. So when I press my down key, excuse me, I need to change my scale here. But you can see it transmits immediately without me even saying anything. I'm dead quiet. It still transmits pretty much the exact same as if I'm talking. And that's because AM sends out a constant carrier wave the second you down key. However, single sideband mode does not. In fact, why don't we go take a look at it? So let me change my radio to single sideband. And that single sideband, it varies depending on your speech. So it will stop emitting the second that you stop speaking. And because of that, as I mentioned before, this relay only opens when it senses RF. So if it's not emitting, or it's if you're not emitting RF, like when you say take a pause in a sentence, or you're a little bit slow in speaking like I am now, you're trying to enunciate clearly, your amplifier will shut off and shatter because the SSB isn't opening the relay. In fact, I can demonstrate that. So if I pull out this wire here, I'm disabling my mode select circuit. So there's no mode selection at all. And I'm just going to turn the power down a little bit to 0.5 just so we don't damage anything accidentally. And I will put this one in bypass just so that, again, we're not damaging anything. And listen to the relay. So, excuse me, I'm still in AM mode, pardon me. Excuse me, I needed the amp to be on. Yeah, silly. Been up all night, excuse me. So now let's listen to the relay when we transmit. So we're in upper sideband. I should mention we use upper sideband in the upper bands, lower sideband in the lower bands. So no mode select, let's go. You can hear the relay chattering because it's not going on, right? So let me talk into it. Hello, hello, hello. Hello, hello. You can see when I whistle, it's getting a more constant signal, so it stops chattering. But once I start speaking, it starts to chatter because it's not emitting RF during certain inflections and so on. And so that's not good. So how do we deal with that? Well, we deal with that by increasing the a specific capacitor to increase the delay time of the relay. Basically, we want to force the relay to stay open longer. So typically these little boards like this would be designed and built to be tuned to either AM or SSB. But that's not great. We want to have both modes. So we designed a little off board right here to have a capacitor tuned for both AM, which is about 10 microfarads. AM you can kind of get away without capacitance, but it's better to have a little bit of capacitance to just force the relay open just a little bit in case of any weird factors. So for AM, we have our switch, and it switches to 10 microfarads. But for our SSB, we have a 100 microfarad capacitor, and this really forces the relay to stay open during speech, so it doesn't chatter. And so you just recently heard the chatter. Well, now I've plugged in the circuit back again. I have my switch set to go to the SSB capacitor. So why don't we try transmitting now with the mode select switch on and listen to our result. Testing. This is VA7HTG testing the amplifier with the mode select switch on with our capacitor. As you can hear, there is no more chattering. The relay is staying nice and open. I can even stop speaking for a second, and it still sounds nice and good. So that's why we use the mode select. And now let's get a little view at the power out. I'll go back to 1, just because we didn't show any 0.5. I was just doing that when we had the mode select off, so it wouldn't damage anything. So now let's go look at our meter. So let's go. This is VA7HTG testing amplifier at 1 watt of input power. As you can see, this is why we don't use SSB for our power in versus power out graph. Its output is very volatile in terms of recording. It's very much dependent on how it's being spoken into, or just constantly. Like I'll use a whistle as an example. Like if you can get a good whistle, it will stay consistent, but speech, it varies. So it's a bit harder to get a good output graph, which is why we chose AM for the output. But we want to have single sideband functionality because single sideband is more commonly used in amateur radio activities. And now I'm going to show the mode select. So I'm going to switch my mode to AM. So I'm sorry, I just have to use 2 hands real quick. So now I've switched it back to AM. I'm going to switch my radio over to AM. So now we're back on AM. And now let's go check. So let's go. This is VA7HTG, back to AM mode, back to AM mode. I'm not going to speak and watch the power stay constant-ish. And as you can see, the radio is operating as intended. Sorry, the amplifier and the radio too. Stay tuned for the next video. We're going to test it on a different radio. Alright, welcome back to the last video of testing the amplifier board on its own before it's assembled into the final amplifier full system with all its subsystems. So before we were testing on this little Uvic ECE transceiver, excuse me, I'm a little tired. This is kind of the perfect size of transceiver for this amp because it has a 0 to 10 watt output power, which is perfect. It quite literally matches the exact 0 to 10 watt input for this amplifier. But now we're going to test it on this Yaesu FTDX 101D. So this amp radio goes from about 5 watts to 100 watts. So this, you wouldn't typically attach an amplifier like this to this radio. You usually go for something a little bigger, kind of like this Elecraft here. But it's a good test to show that this radio can operate on multiple units. It's not linked to one kind. It's versatile. So first we're going to just transmit, we're going to test, we're on the same frequency if you notice. I'm transmitting from, this radio has 2 receivers, so and transceivers as well. So I'm transmitting from the left one, so 2400, or 28 megahertz, 28.4 megahertz, excuse me. let's check our power output. We want to make sure that we are below 10 watts, because as I mentioned, this can do up to 100. If we put that high RF in that amplifier, it will blow. So we are at 5 watts at the minimum, or the minimum this one can go, the lowest. We are on AM mode. And so let's go take a look at our meters, and I'm going to test. Let's go test, 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 test. So it looks like we're getting about 100 and, let's see, a little bit variation, but about 110 to 130 watt output. Comparing that to what I recorded for the Jaigu, it got about 107, so it's not too far off. Let's do another test at 5 watts. So test, 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 test. Yeah, what do you know, about 111, so quite similar. That's looking very good. Now let's just do a quick test on a single sideband as well, just to show that, yep, it verifiably works on both. So let's change our mode. This one's a little bit trickier to mode change, so we need to hold down this mode button here, and then click on the upper sideband. So now we're on upper sideband. Let's go swap our mode select switch so we don't get any relay chatter. Oops. And give her a test. Hold on. Let's go over, and this is VA7HTG testing upper sideband. Testing upper sideband. This is VA7HTG testing upper sideband. Yeah, so it looks like it's going good. This meter doesn't quite love upper sideband as much as the lower one does. The lower one picks it up quite well. The upper meter is not loving it as much, which is interesting. I'll have to take a look at that. But as we can see from our needle meter, which is our more accurate meter anyway, it measures it quite well. You can see it's bouncing around, but approaching 100 if we hello, VA7HTG testing. So as you can see, SSB is working quite well as well. Thanks for tuning in, and stay tuned for the final product.